how to write answers. We say this now. We put here this normal reaction. But now this time the lift is moving upwards. So using, you come and said using F is equal to MA. Then you come to the other formula that we have got, which is we said R is equal to MA plus MB. Are you together? Are you together, members?
Yes.
Yes. So that's how you present answers in exam. Now moving forward, let's look at what about when the lift is moving downwards? What happens to the person? What happens to the person? What happens to the person? Then after that, we go and we come back and then we look at calculations which involve this. This is the thing we are talking about. C. Let's look at C. C. When this is a lift moving downwards. Lift moving downwards. If you don't want to use the word downwards, you use the opposite of ascending, which is descending. When the lift is descending like that. Okay? So this time the lift is moving downwards. So we said when the lift is when a person is moving in the lift and is accelerating upwards, the person feels heavier. Now this time when the person is moving downwards or descending in a lift, the person feels lighter. The person feels what? Lighter. So let's put this statement down. So we said when a lift is moving or descending or decelerating, those are the words you use. When a lift is moving or descending or decelerating downwards, moving downwards, the person feels lighter. Okay? Why? This is because the reaction force to his or her weight is equals to the difference. This time is the difference. The other one was sum. Is equals to the difference between is or her actual weight and the resultant force. That is the reason why the person feels lighter when the lift is moving downwards. Then now we can consider diagrams. You can draw that diagram now. You are in the lift. There you are. Please use a ruler. Don't use a free hand like me. Use a ruler to draw. Can you like copying and pasting what the teacher is doing? Please, for you, use a ruler. Use a ruler so that you draw a good diagram. Weight mg. There's a reaction there. R from the floor of the lift. This time, the lift is moving downwards. So the acceleration will be downwards. So A meters per second squared. So we come and say using F is equals to MA. So in this case, our resultant force, this time the lift is moving downward. So this is going to be the weight. Okay? So it's going to be this force minus that. It's going to be this one minus that. So it's going to be mg minus r. equals to MA. So you find that when I make R the subject, I take by taking R this side, then I bring MA this side. So you find that we shall have MA minus MA, MD, sorry, minus MA equals to R. So therefore, the reaction R will be equals to MD minus MA. So that's what we are talking about here. That is what we were talking about here. This is because the reaction force to its or R weight is equal to the difference between its actual weight, which is MD, and the resultant force, which is MA. So you can see how that formula comes automatically to that. This formula we have used is just explaining, is giving more perspective on what we have put in words. These are just formulas. This formula will help us in calculation, but when it comes to explanation, these are the words we use. Are you together, students? Are you together on that?
Yes.
Yes. So explanation, you use this. Then you bring in the diagram. Calculations, you use the formula. And I don't want you to cram this formula. Don't cram this formula, because when you cram, it may mislead you. So just follow the concept. Follow the concept. When it's moving downward, which means acceleration must be pointing downward. Then using F is equal to, and the resultant force will be, since it's moving downward, this one will be this one minus that, which is this, must be equal to MA. MA, when you make R the subject, because what is important, what makes the person feel heavier or lighter is the reaction. The reaction you get is what makes you feel either lighter or heavier. Are you together, students?
Yes.
Very good. Very good. Very good. Very good. Very, very good. So those are the three conditions we use. Now there are times, I believe you have all seen, if you have not experienced this, but for me I've experienced it. There are times when you're in a lift, then power goes off. What happens to you when power goes off when you're in the lift?
The lift stops.
Eh? Does it stop?
It will stop working.
The lift stops working and
It will not.
not moving again.
It will.
Can't even open.
It will what? Now this time let's look at the lift. We have looked at the body when it's moving up, down, and when it's at rest. Now this time is the lift falling. Okay, the lift cannot lift itself by we can, for the lack of better word, let's say a lift cannot lift itself. Okay. Okay.
Yes.
So now when power goes off, the lift, let's say D, let's put it as D, lift falling. This time the lift is falling freely because there is no power. Okay, lift falling freely when the lift is falling freely. Can we write this? Let's write this. When the lift falling freely, comma, the person, this time the person feels weightless. You'll be in a state which we call weightlessness. The person feels what? Weightless. You feel like there's no force being exerted anywhere. You just feel like you are not. There's no force acting on you. Okay? Are you together? When the lift is falling freely, comma, the person feels weightless. The person feels weightless. Why? This is because the reaction force through our weight, the reaction to is or our weight is 0. is what? Is 0. Why? Since the resultant force is equals to weight is equals to the weight. Okay? Is equals to weight. Full stop. Not when a body falls freely, comma, its acceleration is equals to acceleration due to gravity. Its acceleration is equals to acceleration due to gravity. So we have seen that when we are looking at motion under gravity. So this time when the body is just falling freely, which means the acceleration A will be equal to acceleration due to gravity. And since it's falling, which means it's going to be positive. It's going to be positive. So we can also, let's have a diagram for that. Members, are we together?
Yes.
All right. The weight is there. There's a reaction. Up there. This time the lid is falling. It's not just accelerating. The lid is falling, which means A is equals to G. So still using F equals to ma. Okay, F equals to ma. So this time now what we are going to have, the resultant force, which is going to be mg minus r, okay, equals to m. Remember we said acceleration is equals to what? G. Which means this one will be equals to also g. So when you collect the terms, when you make r the subject, you find out we shall have mg minus this one, mg equals to r. Now you can see from that formula clearly that r is equals to mg minus mg. Mg minus mg, what do you get, members? Do you get 2 mgs? What do you get?
0.
We get 0. We get what? 0.
0.
That's why we said at this instance, the person feels what? The person feels what? Weightless. Are you together?
Weightless.
The person feels weightless. Why? Because the reaction on the body, the body is what? Is 0.
Okay.
Are you together?
Yes.
That state where you feel you are weightless, that state is called weightlessness. The state is called weightlessness. The state is called what? Weightlessness. Are you together?
Yes.
At that instance, the person, that state is called weightlessness. So if they ask you, what is weightlessness? Or what is weightless? Write this question down. Please. The question is a sample question. Define weightless. Define weightless. Define weightlessness, sorry. Define weightlessness. Define weightlessness. Who can define us for that? Who can define it?
Me.
Yes, who is that?
Me.
Yes, who is that?
Farouk.
Yes, Farouk. Yes.
Farouk.
Yes, Farouk.
I think weightless is when something does not have any body friction or movement in it.
Good trial. It's good trial. Who else? Sandra?
Me, teacher.
Yes, Sandra. Yes, now can you? What is weightlessness?
Weightlessness is the state when a body
When
the body's resultant force is equal to 0.
is equal to 0. Good. Let's write it. Weightlessness is a condition. Is a what? Is a condition or a state. Okay. When the resultant force on the body, is equals to its weight. Is equals to its what? Weight. Okay. Weightlessness is a state or a condition when the resultant force on the body is equals to its what? Weight. Or we can define it the way Naroken has defined it. You can say weightlessness is the condition, when the reaction force, on the body, is what? Now, what did you say? When the reaction force is what?
0.
0. Good. When the reaction force is 0. As simple as
That.
Good. Any questions so far? Any questions so far? Am I clear enough? Am I clear enough, members? Yes, Alex.
Yes.
Alexis.
Yes.
Is this?
Teacher, I have a question.
Yes,
Yes, teacher.
Just on the side.
Alexandra, right?
Yes.
Alexandra.
Just on the, there's a house there and we were wondering, is that long surveillance thing there? Which is high up there. Like you're watching live.
Teacher,
Yes, please.
like for the elevator, when it's falling, does it mean it's really falling, like going down on its own, or it's just remains in the middle?
It's going down. It's going down on its own. Okay. There's no force exerted on it. Okay. That's why we are saying it's falling freely. Something falling freely, which means it's not compelled by another force apart from its weight. Just the weight of the lift. Right together.
Okay.
You have got it. The lift is falling freely.
Yeah.
It's not the person falling, but it's the lift falling freely, and it's falling due to the influence of gravity. That's why we take it. That's why we said acceleration will be equal to acceleration due to gravity. Okay.
Yes.
Right together.
Yes.
All right.
We are together.
Now, after understanding all those, let's just give a simple summary. Now we want to go to calculations. Calculations. Okay? Subheading calculations. We want to see how we can use those formulas. We have put them down. A quick reminder, recall. Reward it. Recall. When a lift is at rest, we said normal reaction will be equal to mg. Do you remember that? Members, do you remember that?
Yes, teacher.
Yes.
That's the first condition. You should,
Yes.
when they said a lift is at rest, you must remember this equation. Okay? What about when a lift is moving upward? When a lift is moving upward, we say the person feels what? Heavier, right? The person feels what? Heavier.
Yes.
Heavy.
So the reaction is equal to MA plus MG. Also remember this. Remember this equation, okay? For calculation purpose. Then Roman 3. What about when the lift is moving downwards? When the lift is moving downwards, the person feels what? Lighter, right?
Lighter. Yes.
So the reaction is equal to Mg minus
MA.
MA. MD.
Then the last one, when the lift is falling freely. When the lift is falling freely, R is equals to reaction is equals to
0.
0.
And now this is what we refer to as weightlessness. Okay, what we refer to as what? Weightlessness. The first one is it? Are you together, members?
Yes.
Yes.
Good. Now, if we can remember all this, now let's go to questions now. Examples. Let's go to questions. Examples. Let's see. I see this question here. This one here. I see this example here. On the note, the one on the note, on the screen, sorry.
Yes.
Who can read? Who can take us through that question? Someone to take us through that question? The one on your screen, that example on your screen. Yes? They're saying a lift move what?
A lift move up and then down. A lift moved up and then down with the acceleration of 3.
So let's be collecting data. Let's be collecting our data, okay? So acceleration.
I wish I saw your heart jump out
Acceleration
your
was
mouth.
given to be 3 meters per second square. That's acceleration, right? What do they want us to do? They're saying calculate the reaction by the flow on the passenger of mass. So mass was given. Mass was also given. Mass was given to be 60 kilograms, right? Calculate the reaction on the passenger of mass 60 standing in the lift in the case. So we have two cases there. One, when the lift is moving upwards motion. Then 2, downward. Downward what? Downward motion.
3 meters per second
Are you together?
squared.
Are you together?
Yes.
So
Yes.
let's start with part A. They want us to find the reaction. Reaction R. So when the lift is moving upward, we said when the lift is moving upward, the reaction is given by R is equals to. So let me give a simple sketch diagram. Let me give a diagram for that so that you can see. I don't want to cram, please. Don't cram. Don't cram.
Network is terrible.
We have that. The body is there. The reaction is there. This time the lift is moving upwards. The lift is moving upwards, so acceleration was given to be 3 meters per second squared. 3 meters per second squared. So this is our reaction R. weight m, which is mg, So using our formula, using F, don't cram the other formula we have already derived. So F is equals to ma. So now when we get the resultant force, so it will be R minus mg. So R minus mg equals to m what? Ma. So the reaction R they are asking for, so it implies that R will be equal to ma plus m what? Mg. Are you together?
Yes, teacher.
So we have derived the formula. Now what are we left with? So we can go ahead and even simplify our calculation. So our R will be equals to, what do you see? What is common here? M is common, right?
Yes.
You can factorize it out. So when you factorize it out, we shall have M into A plus what?
Plus 2.
After that, now make the substitution. Go ahead and make the substitution. Let's go ahead and substitute. So our R will be equals to the mass. What was the mass of the body of the passenger? What was the
60
mass?
kilo.
60. Into what's our acceleration? A is what? 3. Plus what is acceleration due to gravity? 10. Not so.
10.
So we shall have R is equals to 60 times what? Times 13.
13.
So our reaction will be
780.
We shall have 60 times.
1 day.
So we get 700 and what?
80
Do you leave just like that?
newtons. 780 newtons.
Newtons. Now okay, very good. Are we together on that?
Just remove
Yes.
your colleague.
Yes, teacher.
Okay, I've removed.
Yes, teacher.
That is when the leaf is moving upward. Okay?
Yes.
Let's also do the same when the leaf is moving downwards. When the leaf be downwards. This time the leaf is moving downwards. You do the same. You sketch so that it helps you to derive the formula to use. You sketch. Mg. The reaction is there. R. This time the leaf is moving. What? Downward. So our acceleration is still going to be 3 meters per second because they say when you look at from the equation, the leaf move up and then down with an acceleration of, so acceleration will still be what? 3. Okay? Remember, is it okay?
Yes.
Yes, teacher.
Okay. So using F is equals to MA. Don't just quote formula, please. Don't just quote formula. Unless otherwise. F is equals to MA. So this time the leaf is moving downward. So which means the reaction will be Mg minus what? Minus R. So it implies now we shall have Mg minus R equals to M what? Ma equals to
MA.
So when we make R the subject, so we shall have Ma minus M what? I mean Mg minus Ma equals to R, right?
From last night.
So it implies now our R is equals to M what? Mg minus M what? Ma.
MA.
So when you factorize it to make our substitution easier, we shall have M into D minus what?
A.
Minus A. But our D is equals to 10 meters per second squared. Okay? So it implies now our R will be equals to our mass, which is 60, 60 into, what is the acceleration? The acceleration is 10 minus acceleration due to the lift, which is 3. So we shall have our R is equals to 60 times what? 60 times
60 times
times 7. So 60 times 7, what do you get? You get 420. 420. So you can see clearly from those calculations that when a lift is moving downwards, the person feels lighter. The person feels what? Lighter. You can see this one is only what? 420 newtons. But when it was moving upward, the person the reaction was 780 newtons. So that one clearly can give you that when the person is moving up, the person feels heavier. But when he's moving down, the person feels lighter. Are you together, students? Are you together?
Yes.
So now what I want you to do, are you seeing questions which are there? This question, are you seeing these questions here?
We are seeing.
Yes. If you don't have the notes, go and download the notes. Then try all of them. Try all of them.
All the activity.
Yes, all of it, all of it. Test yourself. Go and test
Yes.
yourself. Okay?
Yes. Yes.
If there's no any question, then start doing it even now.
Yes.
What's finished? What's finished number 1? I'm waiting for answer for number 1. We must all be doing it now. Following all the concepts we have looked at. Following the concepts we have looked at. Yes, what's got answer for A? I mean for number 1? Yes? Sorry. Yes, members, I'm waiting for answer for number 8. For number 1, sorry.
kilograms. The answer is 50 kilograms.
60 Newton.
Yes.
Kilograms, man.
What's finished A? I mean number 1?
50.
The answer
50.
is
50 kilograms.
50 kilograms.
they're asking for?
Mass.
Mass.
Which formula did you use?
Mass.
Which formula did you use? You said force is equals to
Force is equal to mass.
Not so.
MA.
What about number 2? Number 2? For A, mass is equals to 50 kilograms. That was correct. What about question 2? Question 2, they're saying a car of mass was given to be 1,200 kilograms. Moving with a velocity of, so velocity was given to be 50 meters per second. Is retarded uniformly to rest. Members, are you seeing that? Is retarded uniformly?
Yes.
Retarded means what? It's decelerating, not so. Retarding mean is what?
Decelerating.
Decelerating. To rest in 10 seconds. So time was given to be 10 seconds. Time was given to be 10 seconds. Now they're asking you what is the retarding force? What's the retarding force? Now, what you need to know from here, so they're saying, which means the initial speed of the car was, you shall take this one as the initial velocity, which is it? This will be our u. Okay? Are you together? So this will be our initial velocity. Then the final velocity, now when the body was at rest, was brought to rest, so which means the final velocity will be what? Will be 0 meters per. So when a body is being brought to rest, the final velocity will be 0. But when it's starting from rest, the initial velocity is 0. Have you got the difference now there?
Yes.
So now if that is true, because now they want us to find the retarding force, and remember is retarding, which means the answer we get must be negative. Okay? Retarding force is always negative. Retarding force is always negative. Are you together? It's always what?
Yes.
Negative. Let's prove that. So we said using F is equals to M what? MA. Okay? But U is equals to U. Do you remember that? So from that, if I make A the subject, our A will be equals to V minus U out of T. Are you together?
Yes.
Members, are we together?
Yes.
So it implies that our F will be equals to M into our A, which is V minus U out of T. Okay? So now when you make the substitution, our F will be equals to, what was the mass of the car?
100.
1,200.
Into
1,200.
what's the final velocity? Is what? 0.
50.
Minus
0.
Minus 50.
Divide by the time of impact was 10 seconds.
10.
So we shall have our force F will be equals to 1,200 into 0 minus this give us negative 50, not so?
Negative 50.
Out
Yes.
of 10. Divide by 10, that one will give us that. We find that our F will be equals to 1,200 times negative what?
It's not there, maybe.
Negative 5.
So therefore, our force will be equals to, what is the answer? Who has got the answer, please?
Negative 6,000.
Negative what?
Negative
Newtons.
6,000
What?
newtons.
Newton. So what does the negative mean? The negative means the body is what? The car is retarding.
Retarding.
That's why I said retarding force is always negative.
Negative.
Are you together?
Yes.
So continue. You do number 3, number 4, number 5, and then number 6 and number 7, and you submit. I want to see the work before Monday. Okay?
Yes.
Are you together?
Excuse me,
Yes.
teacher.
Yes. Our time is almost.
Let me take a look. Let me take a look at number 6 and 7.
Number 6 and 7 is here.
Yes.
You have seen, eh? This book is there on the website. Go and download it, okay? Okay?
Yes.
Okay, members. Have a nice day. Thank you for attending.
Bye.
Okay, teacher.
I love you all.